Hey guys, we're going to take some notes on ratios, so make sure you turn to the page in your booklets that looks like this one. Ratios are a way of comparing numbers. They can be written in three forms mostly. The ratio of triangles to squares can be written 1 to 4, 1 to 4, or 1 to 4. Notice that the order of the words needs to match the order of the terms. So for instance, the words triangles comes first, so the first number refers to how many triangles there are. The word squares comes second, and so our second term talks about how many squares there are in the picture. So now let's fill in the second one. The ratio of circles to triangles can be written, so let's count our circles. We have 1, 2, 3 circles, so that'll be our first term. And then we're going to put a colon in between for our first way of writing the ratio. And triangles is our second word, just one of those. So 3 to 1. And then we can write it in this form that looks like a fraction. 3 to 1. And we can write it with the word 2 in between. 3 to 1. So notice that the top term in the fraction is like the first term when we write it horizontally. Ratios can also be written as a decimal if we were to do top divided by bottom or first divided by last. All of the above ratios would be read, in this case, they would all be read as 3 to 1, no matter which one they look like. There's two types of ratios when we deal with a group of objects. We could write a ratio as a part to whole, and this is like a fraction. Or we could write it as a part to a part, just to compare two different groups. First, let's look at the part to a whole. You can use ratios to compare part of the group to the whole group. This is like a regular fraction. So in this case, the ratio of circles to all shapes is 3 to 8. So you'll notice that there's 3 circles, so our first term is 3. And then when we look for all shapes, notice that we need to count the circles again. So there's 1, 2, 3, 4, 5, 6, 7, 8. 8 shapes in all, including the circles. So the ratio of circles to all shapes is 3 to 8. 3 to 8, or 3 to 8. Now let's take a look at the ratio of white shapes to all shapes. So if we notice, there's only one shape here that's white. So it's 1, and we already counted the total shapes in the last question, so we remember that it's 8. So 1 to 8, 1 to 8, and 1 to 8. Alright, so the first type of ratio is looking at a part of the group compared to the whole group. Now let's look at our second type of fraction, or second type of ratio. It does not operate like a fraction. It's a little bit different. This is where we compare two different parts of the group. This is very different from a fraction because we'll often end up with a bigger number at the beginning than the end. So the ratio of squares to triangles is 1, 2, 3, 4 squares and 1 triangle. The ratio of triangles to squares then, remember that the terms need to match the words, so we need to flip these around. 1 triangle to 4 squares. You'll notice that ratios are not written with labels, but we can go back to the words in the question to tell us which group is which number. The ratio of circles to the rest of the shapes. Now this is a question that often confuses people because it sounds a little bit like all. But when we say all of the shapes, we mean the whole group. When we say the rest of the shapes, we need to take the first group out of it. So the ratio of circles to the rest, circles are 1, 2, 3. So 3 is our first term. And then to find the rest of the shapes, we don't count the circles again, but count everything else. 1, 2, 3, 4, 5. So the ratio is 3 to 5. And you'll notice when we have one like this that talks about one group to the rest, when we add the terms, 3 plus 5 is 8. We should get the total number of shapes. The ratio of striped shapes to other shapes is, well, let's take a look at this. Our striped shapes, we only have these squares here that are striped, but not all the squares have stripes. So 1, 2, 3 shapes that are striped. Now other shapes is like saying the rest of them. So the other shapes are just these 5 over here. 1, 2, 3, 4, 5. So our answer is 3 to 5. Alright, that's the two types of ratios that we're going to be looking at when we compare a part to a whole or a part to a part. Sometimes we need to make the ratios have the same units. If they both measure the same thing, we're going to need to change them so they have the same units. Sarah and Jack here entered balloon-powered race cars into their school's science Olympics. The race was to see who got the greatest distance. Sarah's balloon-powered car traveled for 2 meters, while Jack's car traveled 35 centimeters. Now we have a problem here because we have two different measurements, but they're both measuring distance. And the problem comes in that we can see that Sarah won because her car went 2 meters, while Jack's only went 35 centimeters, not nearly as much. But the way the numbers are, if we write these out as a ratio, 2 to 35, it looks like Jack's car went a lot further distance here. Well, that doesn't show the true relationship of their distances at all. So what we need to do is we need to convert one of these measurements to match the other one. So let's get rid of this ratio that doesn't really show the proper distance. And let's look at another way. What we need to, the easiest way to do it is to always convert the bigger unit to the smaller units. And we can do this by multiplying. We know that there's 100 centimeters in a meter. So we can take our meter measurement, which is 2, and times it by 100 to change it to centimeters. So 2 times 100 is 200. So while Jack's car traveled 35 centimeters, Sarah's car traveled 200 centimeters. And now our numbers make sense with what we already knew, that Sarah's car actually went further. And we could write the ratio as 200 to 35. These measurements are now both in the same units. They both talk centimeters, and so the ratio now shows an accurate relationship. So anytime that the units measure the same thing, in this case distance, you need to convert the units so that they both are using the same measurement. So here we've now made them both centimeters. Sometimes this also works with time. Sometimes one measurement would be hours, and one measurement would be seconds. We need to convert one of those so that both of them measure the same unit of time. Now here's a chart that shows some of the common conversions that we would make. So you'll notice that these all go from the bigger measurement to the smaller measurement. So in 1 kilometer, there's 1,000 meters. And 1 meter is made up of 100 centimeters. 1 gram contains 1,000 milligrams. And remember that in this case, meters and grams could trade places at any point, and also liters could be used in there as the unit of measurement. Down here we have some units of time. So in one day we have 24 hours. There's 60 minutes in 1 hour, and 60 seconds in 1 minute. So then if we needed to know how many seconds in 1 hour, we would just take 60 times 60 and end up with 3,600 or 3,600 seconds in 1 hour. So let's just do these conversions here. Here we have 3 kilometers to 75 meters. They both measure distance, so we need them to be in the same units. So we take the larger one, which is 3 kilometers. We multiply it by 1,000, which is how many meters are in 1 kilometer, times 1,000. So 3 times 1,000 is 3,000 as our first term, and then 75 can stay as the second term. Now if we have 128 centimeters to 2.5 meters, we're going to take our larger measurement, which is meters, and change it to centimeters by multiplying. 100 centimeters in a meter, so we'll times this by 100. Remember that multiplying by 100 just kicks the decimal over 2 places. So then we have 250 centimeters. Now we can write our ratio as 128 to 250. Seven grams to 350 milligrams needs to have milligrams instead of grams, so we'll times that by 1,000, which gives us 7,000 grams, or 7,000 milligrams, sorry. And now our ratio is 7,000 to 350. Now let's try some units of time. We have 2 days to 32 hours. Days is our bigger unit, so let's multiply that to make it into hours. So 24 hours in a day, so 2 times 24 gives us 48 hours. And now our ratio is 48 to 32. To make 45 minutes to 1 hour into a proper ratio, we're going to change the hours, which is the bigger unit, into minutes. So there's 60 minutes in 1 hour, or we could say 1 times 60 is 60. So our new ratio would be 45 to 60. We have 300 seconds to 3 minutes in this case. Minutes is our bigger unit, so we're going to multiply that by the 60 seconds in each minute. And we get 180 seconds. And so now our ratio is 300 to 180. And our last one is going to be a big number because there's a lot of seconds in an hour. So we're going to take our 2 hours and times by 3,600 seconds. And we'll get 7,200 seconds in 2 hours. So then 7,200 to 80 is our final ratio. So just remember, if our units are measuring the same idea, in this case here distance, in this case here mass, and in these cases down here time, we need to make sure that they're measured in the same units before we write them as a ratio. Okay, we finished the notes section here. Now you can move on to the next page, which is your assignment on ratios.